All right, guys, let's take a few minutes and finish the back side of the online review. And the back side really involves a lot of solving. So up here, solve the following. And you want to think about what justifies each step, because what we want you to realize is that every step, every equation that you write is just an equation that's equivalent to the original one. And I like to get rid of my fractions. So you can multiply both sides of an equation by the same value. In geometry, we call that the multiplication property of equality. But you could just explain it as I'm multiplying both sides of the equation by the same value in order to create an equivalent equation. So that would cancel the 3. And on this side, if you distributed, you'd have 2x minus 20. On this side, if you distributed, the 12 times 3 is 36 plus 3x. So if you subtract 2x from both sides of the equation, again, that makes an equivalent equation. And then you can subtract 36 from both sides of the equation. Again, in geometry, we call that the subtraction property of equality, but you can describe it in your own words. That would be negative 56. And all of these equations are equivalent to the original equation. That's why when we get our solution of negative 56, we also know that it would solve this equation and this one also, because they're all equivalent. The same thing works for inequalities. So I'm going to go ahead and distribute. We'll use the distributive property. Negative 3 times w, and then the negative 3 times the negative 5 will give me 15. So now I can combine my like terms. Again, terms like the distributive property are combining like terms. Those are good vocabulary terms to use. This would make negative 1.5w if I combine those terms. So I can subtract 15 from both sides of this inequality to make an equivalent inequality. So 42 take away 15 is going to give me 27. Now, just a little reminder, you can divide both sides of an inequality by the same value. So I can divide by negative 1.5, but you have to be careful, because if you multiply or divide by a negative number, that is going to reverse the direction of the inequality. So when you take this, it's no longer less than or equal to. Our solution now is w is greater than or equal to 27 divided by negative 1.5, and that's 18. Again, the idea being this is our solution set. All values of w that are 18 or larger will satisfy all of these equivalent inequalities. It will make all of them true. Question number 8 is just using an equation in order to solve. You want to write an equation to determine this unknown number. We'll call it x. And then we want to find that number. Well, the trick is to read this a couple of times. Half of the sum of a number and 5 plus negative 8 is 23. So the is where our equation will be when we translate this into algebra. But what's important is to recognize that what we're taking half of is this, the sum of a number and 5. So the number we don't know, that's the x, and we're taking the sum of the x and the 5. And that's what we're taking half of. So if I wrote this equation, I would take the 1/2 and I'm multiplying it to the quantity x plus 5. So half of the quantity x plus 5 plus a negative 8, that's what's going to equal my 23. This is the equation then that we needed to write in order to determine our number. Now we can find that number. So I would add 8 to both sides first. So adding 8 to both sides of the equation, 23 plus 8 will give me 31. And then I would multiply both sides of this equation by 2 so that I don't have to work with the fraction anymore. So if I multiply both sides of this equation by 2, the 2 times the 1/2 makes 1, and distributing 1 through the parentheses doesn't change anything in the parentheses, so it's still x plus 5. And on this side, the 31 times the 2 makes 62. And then if I subtract 5 from both sides of the equation, that gives me 57. And we can actually check ourselves. So if you take 57 plus 5, that gives you 62. Half of 62 is 31. And 31, if you add negative 8, really does give you 23. So this is another type of inequality that we can solve, but it's called a compound inequality because I have inequality symbols on both sides of the expression in the middle. So I can subtract 4 from all components of this inequality, and I can make an equivalent compound inequality. So the 4 minus 4 leaves me with adding 0 in the middle. So 12 minus 4 gives me an 8. It's still less than or equal to a 1/2 x, and that would be less than or equal to 18 minus 4, or 14. So to get rid of the 1/2, you can think of dividing all sides by a positive 1/2, or you can multiply all sides by a positive 2, but because it's positive either way, it's not going to change the direction of the inequality. So I'm just going to think of it as multiplying by 2. 8 times 2 would give me 16. The 1/2 times 2 gives me a 1, or 1x. I don't need to write the coefficient of 1 in front of the x. So the 14 times 2 gives me 28. So this is my solution set, and to graph it on a number line, not particularly fancy, I'll start with 0. 1, 2, 3, 4, here's 5. 6, 7, 8, 9, here's 10. 15. 20, always good to label carefully. 25 will go up to 30. So I want to include all of the values from 16 to 28, and because it includes, it's less than or equal to the 16, I want to put a solid dot at 16. So if this was strictly less than, 16 was strictly less than x, I would want to use an open circle there. So same thing, ending with 28, and I want to include the 28, so I'm going to put a solid dot there. And then to represent that I'm including all of the numbers in between those two dots, I would just shade and make a line segment between those two dots. So this is a graphical representation of our solution set. So sometimes you can solve, but you're working strictly with variables. That's okay. So solving for W doesn't mean we're going to be able to find a numeric value for W. What it really means is we want to isolate the W. I want to rearrange this expression so that the W is by itself. So let's take this AX and subtract it from both sides of this equation. So I can write this as W over C equals B minus the AX. And again, to get the W by itself, I need to eliminate the division by C. Well, we know that the opposite of dividing by C would be multiplying by C. So if I take this expression and if I multiply both sides by C, so be careful over here, I have to multiply this entire quantity, this entire subtraction problem by C. That will cancel my C's. So I can write W as, I suppose you could stop right here and simply write B minus AX, that quantity times C. That's one way to have solved the equation for W. It would be also perfectly fine to distribute the C through the parentheses. So you could write this as B times C minus A times X times C. That would be okay. But the point here is you can't solve for a particular number. You're isolating the W. You're writing an expression to get the W by itself. So another type of equation that we would want you to be able to solve along with equations that are linear equations or inequalities, we would want you to be able to solve absolute value equations. So remember, if I want this expression on the left side to make a positive 8, that can happen in two ways. Either what's inside the expression is already an 8, so when I take the absolute value, I've got 8. So that's one way that it can happen. That's my first case. Or maybe what's inside of the expression is negative 8, so that when I take the absolute value of it, I get a positive 8. So the other case is maybe that W minus 3 is actually equal to negative 8. So there are simply two cases to solve here. So if I add 3 to both sides, 11 is one possible solution. Or here, if I add 3 to both sides, the other possible solution, the negative 8 plus 3 gives me negative 5. So there are two possible answers to this absolute value equation. And you can check yourself. 11 minus 3 would be 8. The absolute value of 8 is certainly 8. If you use negative 5 minus 3 is negative 8, but the absolute value of that would be positive 8. So we really do have two solutions. And we can do the same thing over here. It's just that before we break up our expression into two cases, we should isolate the absolute value. So like in number 10, we isolated W. We got it by itself. Same thing in number 11. I want to isolate by dividing both sides of my absolute value equation by 2. So the absolute value of the quantity y minus 5 is going to equal 7. Again, I have two cases. Maybe the y minus 5 is already positive 7, or maybe the y minus 5 is negative 7, so that the absolute value of it will make the positive 7. So I can write it that way. Y minus 5 equals positive 7, or it equals negative 7. And then I can solve these simple expressions. Adding 5 to both sides would give me 12. Or here, adding 5 to both sides, the negative 7 plus 5 gives me negative 2. There are my two possible solutions. So what I want you to see then finally is what the shape of an absolute value function looks like. So what I did here, I wanted to remind you, a simple way to graph is just to make a table of values. So I'm just going to take some particular x values, substitute them into this expression so that we can simplify this to find our y values, and we can plot them. And then I think you'll recognize the absolute value shape. So negative 6 plus 4. That gives me a negative 2. The absolute value of negative 2 is 2. 2 minus 1 is 1. Negative 5. Negative 5 plus 4 would be negative 1, but the absolute value of that would make positive 1. 1 minus 1 makes 0. Negative 4. Negative 4 plus 4 makes 0, and the absolute value of 0 is just 0, so I'm left with just my negative 1. At negative 3 plus 4 is a positive 1. The absolute value won't change that. It's still positive 1. 1 minus 1 is 0. Negative 2. Negative 2 plus 4 gives me 2. The absolute value of 2 remains 2. 2 minus 1 is 1. So I'm simply making a table of values that I can use in order to make my graph. So remember, when you graph, you need to make and label the x-axis and the y-axis. Make sure you label them. Then I'll plot my ordered pairs, and I think you'll see what this function looks like. Negative 6 for x and 1 for y. There's negative 6 and positive 1. Negative 5, 0. There's an x coordinate of negative 5. 0 for the y coordinate means I don't move up or down any. Negative 4, negative 1. X is negative 4, y is negative 1. Negative 3, 0. And then negative 2, 1. So the absolute value function creates this v-shaped function, and it is a function because it passes the vertical line test. So the three main types of functions that we've been working with to review, we have the absolute value function, that gives you your v-shape. Then when you have functions of the form y equals mx plus b, those are linear functions. So if it's a positive slope, it slopes upwards. If the slope is negative, it will slope downwards from left to right. And the other type of function that we've worked with, ax squared plus bx plus c, this would be a quadratic function. That would give us a parabola. Of course, if the coefficient on x squared, if that is negative, instead of a parabola that opens upward, we would have a parabola that opens downward. The point, though, of this last question was to recognize we were solving absolute value equations up here, but we can also graph absolute value functions. And if you didn't remember that that function was a v-shape, that's okay, because when you graph, a simple way to graph is simply by making a table of values.